I'm your host, Jacqueline DiGregorio. The global 3D bioprinting market is expected to reach $4.1 billion by 2026, according to a new report by Grand View Research. Growing use of 3D bioprinting in cosmetic surgeries and innovations are expected to propel the market growth. The technology is commonly used to print prosthetics and dental accessories, medical devices, and bone implants. The medical application segment is projected to expand at a significant pace, which could really change the way we treat certain life-threatening diseases like cancer. My guest host today is Frank McKinney, who sits on the board of Allevi 3D. Your background is investing in the biomedical world. Welcome to UAF Rec Studio. Frank, why and how did you get involved with the company?
Well, thanks. Yeah, certainly. A friend of mine that works with Penn Innovations told me about the company and thought that with my background I could help. I like to help startups and new companies and was really thrilled to meet the team at Allevi.
That's wonderful. What a great relationship. They're very lucky to have you. So Frank, let's introduce the CEO of Allevi, Ricky Solorzano. How would you describe Ricky?
Well, Ricky's he's a true entrepreneur and he's exactly the right kind of person you want running a company like that. He's energetic, he wants to change the world, but he knows how to do the simple things that get things done.
That's amazing. We're so glad to have you here, Ricky. So Ricky, you studied biomedical engineering at the University of Pennsylvania. Can you tell us a little bit about when you started working on the idea to merge 3D printing with biomedical science?
So it was very interesting at the time. There were a lot of companies taking the idea of making large, clunky, expensive 3D printers and making them small, powerful, and easy to use. And they were doing it in carbon fiber, in plastic, in SLA. And I was working out of a lab where an individual had been able to start printing, he made his own 3D printer, and we were also trying to pattern certain cells. So looking at just the market opportunity in general, there were big, clunky, expensive 3D bioprinters, but none that were small, powerful, and easy to use. So I asked him if he could teach me how to make some. And lo and behold, one thing led to another. Learned how to make 3D printers, but then took it a step further and said, why don't we start really trying to make 3D bioprinting? And our claim to fame is we made the world's first ever desktop 3D bioprinter.
Wow, that is absolutely amazing and so innovative. So I would love to understand a little bit more about the process. So we have these little 3D printed coasters that UAF printed. And I would love if you could share with us what the difference between printing 3D something like this versus 3D printing cells is.
So in general, 3D printing in all cases is pretty much the same idea in the sense that you're trying to make a liquid into a solid and create a structure, even like this cup, layer by layer. So in the plastic world, you're basically taking plastic, making it liquid, and solidifying it as it comes out the nozzle, and making this, like say the shape of the cup or the coaster. In the bioprinting world, we think about what are the materials that our own human cells like, and how can we take these materials and control them into patterns. And so let's say our own bodies are made up of like 70% collagen. And so a lot of what we do is figure out how can we take collagen and make them into simple designs like lines, dots, circles, and squares. And then on top of that, so we make those into lines, and then on top of that we infuse cells. And what that allows us to do is pattern those cells in different geometries. And it's relevant because our own bodies have geometry. Both on the micro scale, our hearts are in lines, our livers are in circles, our bones are in squares. And on the macro scale, like an ear, the size of an ear is important, or the size of a nose, or if there's a specific bone defect. That's really, how bioprinting begins to play a role in the overall tissue engineering community.
Wow, that was a really great example of how to actually picture it. Thank you for sharing that. So does the bioprinter actually work with live cells? And what does this mean for scientific research going forward?
So it does, and I actually think that is one of its biggest value adds. And so in general, around the world, biology has been done today by, you basically go online, you go to like an Amazon for cells. And so if you're like a heart researcher, you're like, I go off and I buy heart cells. Or if you're like a brain researcher, you go online, you buy brain cells. And so then Usually, you get the cells, and you just you usually have like a small dish, and you sprinkle the cells on the dish, and then you do stuff to those cells. And they'll usually be in 2D, they'll be random, they'll be sparse, and you add chemicals, and you ask questions, you can add drugs, you can add different chemical factors. And so the thing that we say, though, is that you shouldn't be doing that, because every tissue has a sense of design. So instead of just randomly sparsing the cells, why don't you think of the design? Because usually all these researchers have been studying this for years and years and years. Think about the design, use our platform to be able to input that design, and then instead of taking your cells and randomly throwing in the dish, put the dish in the printer, put the cells in the printer, and then the printer itself will print out the cells in a design that's relevant. And then they do see an enhanced performance out of the tissue that they're studying. So heart cells will start beating on the first day and beat up to 30 days, rather than if they were sparse, they'd start beating in 7 days and only beat for 14 days. Liver cells is the same way. If you put them in circles, you'll see 50% increase in liver protein expression versus if you just have them randomly oriented. And so those kinds of performances is really why how we add value to the world.
Wow, well, it's very exciting to be in this groundbreaking time of research and see how these changes really impact the world. It's awesome. So can you tell us a little bit more about the design of the bioprinting technology? Was it something that already existed? I know you mentioned that you were the first to specifically bioprint or 3D print the cells, but what about the actual bioprinting process? Was that something that you created or already existed?
So when we started the company, I think there were two big, 10x leaps that we made at the time. Because we're always looking for 10x, because that's how we're getting 10x investments and how we're making 10x improvements. And the first one was that we really understood how we can begin to bring down the size and bring down the, at the time it was really about the affordability. If you wanted to access bioprinters of $200,000, $300,000, and we really understood how we can really piece out the components that were most important and still leave all the power into the smaller footprint at a more democratizable access to users, and especially in price. And the second thing that we did is that one of the specific ways that we build these layer by layer of the materials is through light. And so you take the material, you dispense it, and then you use light to shine to solidify that material in place. Beforehand, people have been doing UV light. And UV, cells don't like UV. And so one of the biggest innovations we made at the time as well is we started placing those layers using blue light, using visible light. And so it's actually friendlier on the cells. And that was one of the second biggest innovations we made at the time. And those two things, I think, really propelled us to significance within the market. So,
wow, congratulations. Those are truly very transformational. So you went to University of Pennsylvania, and you're not from Philadelphia, but you decided to grow your company here. So clearly Philadelphia is a great place to run a business. So I would love to hear a little bit more about Philadelphia's startup community and what role it played in helping grow your business.
Philadelphia is great because all the resources are so compact in kind of this one city at a very reasonable distance from it. The lawyers, the bankers, the investors, the hospital, the customers. And so it's about bouncing around, though. And so bouncing around within the city. And it's funny, I think the support that Philadelphia has been able to provide in all those aspects, in all those resources because it takes a village really to make a company, and everyone contributing with a heartfelt, love for the company to continue to see it rise, because companies have so many challenges to get through that, without the support of everyone, it's really difficult to get to the next level. And so it has all this infrastructure in a really small place and a really heartfelt passion to see people successful. And so I think those combinations coming together has really been what the Philadelphia ecosystem has allowed us to, how it has allowed us to thrive and really survive.
Right.
To be able to get to that next level and continue the impact on the globe. Because, as a company, we've had a very global impact that's really started and been supported here right out of Philadelphia.
Wow, it's really special.
So Ricky, what was the greatest challenge in starting the company up and getting it going?
I think probably the biggest challenge is always figuring out what the next step is, So you you get to it's navigating, right? So it's like, okay, we have this product, like, who do we sell it to, or how do we sell it to? Then how do we figure out the price? And then, so always figuring out what the next best questions are is always the biggest challenge, even in the beginning. I mean, when we're, two guys in a room trying to figure out, all right, like, how do we figure out how to hire someone else? Or, oh man, we have to figure out how to buy this microscope. How do we do that? Where do we get money from? Things like that. So I think it's always about, even in the beginning and even now, what are the right questions to be asking to get us to continue to add value as we further the company.
Yeah, so how do you mentor your team to understand the impact that their work is having?
So I think in team-wise, it's always about where have you been, where you are, and where you want to go. And setting up the culture to show that everyone is having an impact. Mm-hmm. So like, because the company is so multidisciplinary. It has software engineers, hardware engineers, sales, manufacturing. It's got all these pieces coming together. And actually in the beginning when we were starting the company, one of the biggest complaints was that, like, I don't know what the hardware guys are doing, and I'm a sales guy, or I don't know what the software guys are doing, and the bioengineers. So actually getting everyone together in a room for an hour a week to share what everyone has been doing, making everyone accountable. So, okay, he's been doing this, he's been doing that, this is what they did last week, this is what we're going to do next week. And so having that accountability in the culture is really, I think, the best way of showing everyone is having an impact. Like, I'm doing my part, and everyone else, and my part is playing a role in this greater part. And so that is almost in itself the best way to have people like, okay, I'm continuing to develop, because I'm not just developing myself, I'm developing with everyone else in this greater, larger goal of the North Star, which is, how can we figure out how to make 3D bioprinting change medicine.
So Frank, your background is in biomedical. Could you describe a little bit about your mentoring relationship with Ricky and how you're able to support him as the company grows?
Sure. So I've been CEO of a few biomedical companies, and running a company takes a lot of work, and there's an awful lot to do. Running a startup is even harder because you don't even have a product to work with. So a lot of working with Ricky, he referred to a little bit before, is prioritizing. You're worried about funding, you're talking about sales, you're talking about engineering, when's the next product going to come out? There's an awful lot to do. So I work with Ricky a lot on priorities, how to make sure things get done on time, and how to integrate all the different pieces. He's done a great job with a very varied team there in getting things done on time and getting them to work. So, but priorities are always important.
Absolutely, I couldn't agree more. It's fantastic, this relationship. It's really clearly built something that's changing the world. So it's an honor to be here with you guys today. Frank, I would love to hear a little bit more about why you decided to work with Allevi 3D and why you saw it as a profitable investment.
Sure. So the 3D tissue bioprinting market is going to be huge. It really does have the capacity to change the world. When you think about replacement organs or testing organ systems in different venues, you can find out a lot more about things with the kind of systems that Allevi is a big part of building. And it's always good to be on the ground floor of things and try to help influence the way that they go. I think it's just it's a great opportunity for not only for investments, and I'm an investor as well, but also for all the stakeholders that you want to see benefit from something like this: patients, the healthcare system, and of course, you always want to do well by doing good.
I love that. Absolutely. It's incredibly impactful work.
So Ricky, let's get into the nitty-gritty of Allevi 3D. You have customers all over the world. How do you deal with all that varied population of people?
On one hand, a really big, great asset that we can leverage is most of our users, even globally, in the science community, speak English. So that already in itself is huge. I think on the other hand, as we've grown the company, we've learned to leverage two things. And one is just distribution. So having local distributors that understand more of the regional culture, that understand more of the regional customs and language. I think one in that self, especially for sales and support, has been a great thing to leverage to be able to house everything in the community. The second is customer support. So really having people that represent Allevi on the ground, just be there to be able to pick up the phone and talk to people. I think the third is communication. So like you want to be constantly, a great thing is email today because you write it once and it goes everywhere. So being able to constantly communicate with your community about what are the latest updates, always, inviting feedback, how we can continue to serve people in a better way, how we can continue to improve, and just really staying kind of in a double-way connection, both providing them information, them providing us information, and really having a strong network of customer support is really how we can kind of maintain the customers that we have and make sure that they can continue to love the products that we produce.
Great, well, thanks. So more of the details. So can printed tissue or cells be used for testing?
So that is the global direction, and I think everyone sees that the value of the technology of 3D bioprinting is going to play a tremendous role in both the drug screening sector as well as the medical device sector. I think part of this is it continues to need validation, it continues to need data. And that's probably one of the biggest questions as a company we have today. How do we continue to navigate through some of that further validation in both directions to be able to assure that the technology continue to have a greater influence and the direct human impact? And so, I mean, as a global company and organization community, we really try to steer both our own scientific R&D as well as our customers towards further validation in all different types of tissues for the advancement of drug discovering techniques as well as medical devices.
So how is 3D testing different than what's done today?
So today, back when I was referring to in the initial example, the workflow today is you buy these cells from some sort of cell Amazon or whatever, and they come, and you sprinkle them on these dishes in a random 2D flat orientation. And so in today's world, that's done in thousands and thousands of tiny little wells where the cells go and they drop them in and they remain 2D. And they're just on a flat surface. But our own bodies are 3D structures, our tissues are 3D structures, and our cells understand their 3D geometry. And so the biggest way that 3D bioprinting is playing a role to change that is by adding in the enhancement of design into these wells. So instead of having cells in a flat 2D, thousands, well, can we now think about, well, if I have heart cells, can I pattern those in lines in the wells? Or if I have liver cells, can I pattern those in circles in the wells? And that in itself is going to have better prediction. Because the problem today is you put a drug on one of those 2D surfaces and it says it's safe. When you give it to a patient, and then you have patients dying because the data doesn't correlate since the 2D surface isn't acting the way that your body behaves. But once you put those cells in lines, and you put the drugs on those cells and lines, then all of a sudden you get better prediction as to how your own body behaves, the body outside the body. So then all of a sudden the cells are going to say, oh, this drug is harmful. It's going to be, and then so you don't give it to the patient, because if you were, then okay, you give it to the patient, that becomes harmful. So that prediction factor, better data, is really the way that adding geometry to biology and modeling the body outside the body is going to be able to enhance the way that we develop drugs in medicine.
Wow. So Ricky, can you give us an example of what body parts you're printing? I know your website has videos of ears and noses printed, which is fantastic. Can you tell us a little bit more about other body parts and what else you print?
Yeah, so it's funny. When we first started, it was, I think the first thing we ever printed was an ear. And it's nothing like a real ear. It's very far from it. I mean, it doesn't really have cells. It does have biomaterials that we were patterning, and it began to give us an imaginational spark to our users around the world of what could be done. But the reality is that most of our users actually print, they're not printing full body parts. They're printing, microstructures, little tiny tissue structures with some pattern. So either it's dots, circles, lines, and squares of different cell types of all across the board. So like brain, bone, liver, lung, kidney, heart, and in these tiny little microstructures. I think we continued to put those pictures on the website because it continues to provide an imagination of what could be done, the future. I think in majority of cases, like I said before, most of our users make those microstructures, and some of our users try to understand the correlative ability of, if I were to take an MRI file let's say for a bone defect or an ear, then how does it correlate to 3D printing some sort of biomaterial in the shape of a nose or an ear? But that's still very far away from actually being a real organ. The most valuable things that users print today are actually small micron directionality, but that is having such an enhancement on all these tissue types across the board. And so that's a little bit of I think what the reality is, why we place those pictures as well online, and where we see the direction going forward.
I appreciate you sharing that. So this is all life-changing, and it's going to help people experiencing deformities and different conditions. However, I know that you're a bit concerned about ethical issues as time goes on. Could you share a little bit about that and maybe what lines you might not want to cross?
I think a lot of people have come back to us and had saying like, ethics is always a question whenever we go on a panel or something, and saying like, oh, what if only a certain population gets organs and another population doesn't get organs, or something like this. And I think number one, I think we're still quite far away from like a heart or lung. But on the second hand, I also think that in general, medical innovation has always had its adoption curves. And so whether if you think about antibiotics, or you think about immunotherapies, or if you think about chemotherapies, or if you think about any drug, has always had to go through its process of how it gets adopted by the greater population, and both in consideration of price and quantity. And there are medical devices today as well that there's some synthetic skins, and those has had to go through its. And this is going to be the same thing, same path. It's going to have to go through its kind of adoption curve. But at the end of the day, economics is going to play out, and the greater incentive is that everyone receives it, that prices is lowered, and that it becomes widespread adopted. So I don't, in terms of ethics, it sounds like, oh, we're printing organs, we're printing this, but in the grand scheme of things, what we're really trying to do is just make an enhanced medical device that already exists today, and it's going to follow that same adoption curve, and it's going to be accepted by everyone because the economics has to play out. So
right, that's a great way of explaining it. So can you tell us a little bit more about who buys your 3D printers, how many you've sold, and if you have any interesting stories from maybe someone who's purchased a bioprinter?
Yeah. So scientists across the world is really who buys the printers today. Scientists trying to understand how they can take advantage of the adding geometry to biology. So really, anyone trying to ask novel questions in any regard, whether it's basic science, drug discovery, medical devices, everyone's asking questions, trying to publish, and that's really where we are in our state today. We serve over like 400 labs around the world, and I think the best stories, are usually found in our publications. We had, I know this year, we had some very interesting neuron work. A guy was literally trying to make a spinal cord, very small spinal cord, but placing cells in a precise way of how he could go around doing that. I think some other exciting ones are even thinking about, cell culture. So again, I refer, instead of sprinkling, how do we think about when we cell culture something, we do it in lattice-based form, or in kind of a cube. Instead of culturing cells in a flat dish, can we culture them in a cube, more like our own human bodies, growing cells? So I really think at the end of the day, the best stories come from the publications and the way that it's showing how geometry really does play a role to enhance the performance of the tissues themselves.
Wow, exciting stuff is going to be coming in the future.
We look forward to it.
Well, thank you so much, Frank, for graciously hosting this episode of OnUp Innovators, and thank you, Ricky, for sharing your story. We look forward to the next evolution in 3D bioprinting. To learn more about Allevi 3D, visit the link on your screen. OnUp Media is powered by the Uncommon Individual Foundation, a nonprofit leader in mentor-based learning founded in 1986 by Dr. Richard E. Caruso. To learn more about UIF, follow the link to their website. Thank you for tuning in. I'm Jacqueline DeGregorio, and I'll see you soon.